Okay, Unit 0, Lesson 2, warm-up. Still talking about inequalities. In word problems, inequalities can be described using many different words. Create an inequality by identifying keywords for symbols using X as a variable. All right, so if you're reading through a word problem and it says, to vote in the United States, a citizen must be at least. So what's the symbol for at least 18 years old? At least. So you have to be greater than or equal to 18, okay? The number of people seated in a theater is at most. That means it can't be more than. So it has to be less than or equal to. Okay, there's 650 seats, so there can be 650, but then, or less than that, right? And in a classroom, you're not allowed to have more than 30. You could have less, so less than or equal to 30. And then apparently the requirement for making a club is no less than, you have to have at least 10 or no less than 10. So it can be greater than 10, but or equal to 10, but not fewer. Okay. Another way to use an inequality: what score will Tyshawn need to have on the final exam to get a final grade of at least 70%? So that means you're greater than or equal to 70. In this case, the final exam is weighted twice as much as any one test. One test, all homework, all quizzes, and other count as 10%. All the grades are given as percentages below. All right, so 50% are the 5 tests. So let me just check. 53, 75, 66, 80, 72. There's the 5 tests right there, okay? All the homework is worth the same as a test. All the quizzes are worth a test. The other, whatever the category is, is worth the same as a test. And then the final is worth 2 tests. So 2 of whatever. So whatever number we come up with the test name to be, there's going to be 2 of them to add to that. And those are the 10 things. If you add them up, that's 10 different things that you need an average for to get your 70. Okay? So if you add up all those numbers, you get 588, and then there's the 2x on the end. Okay, so I just added all these together and rewrote the problem. All right, now what do I do to solve for x? To get x alone, I want to divide by that 10. So that'll give me 588 plus 2x is greater than 700 now. Move the 588 to the other side. 2x is greater than, get up my calculator, 112. X is greater than or equal to 56. So he would need a 56 on the final, which would count twice. And when he averaged in, that would give him a grade of equal to or greater than 70. Okay, because he had good, whatever those were. And I'm just kind of making sure that sounds right. If you have, what's your average of test value? 53 plus 75 plus 66 plus 80 plus 72, 346 divided by 5 is a 69.2 test average. So the average between the 98 plus 59 plus 85, so 30% is about an 81. So that seems about right. So he could do a little less than a 70 here and still pass because of the other grades. So that makes sense. All right, how about this one? A student has a $20 gift certificate to iTunes. She decides to purchase 3 episodes of her favorite show for $2.99. And then is also browsing the music store. They can be downloaded at $1.29 a piece. What inequality would represent the number of songs she can purchase? What is the maximum number of songs she can purchase without exceeding the amount of the gift certificate? So she needs, this whole side of this equation needs to be less than or equal to 20, right? She's just got a $20 gift certificate. So if these are the shows, then how many songs can she download a piece? So what is 3 times $2.99 is $8.97. And then you want to move the $8.97 to the other side. This comes out to 111. Excuse me. Pardon me. Let me check that. 20 minus 8.97 just to make sure. Yep. Divide both sides to isolate our n. N is going to be less than or equal to. I did not divide by a negative, so the sign stays the same. And we're dividing that by $1.29. That comes out to 8.55, and there's more to that. But I'd say you'd be able to get 8 songs. She would be able to purchase 8 songs and use most of the money on the card. Okay? So we need to be able to solve, graph, and give interval notation to the solution of a compound inequality. Compound is joining 2 or more inequalities together. So we have a couple of kinds of those. The first one is called an OR inequality, which is it's the same as either or union. Something can be this or that. We want a true statement from either one of the inequalities or the other or both. So you want to sketch each one separately and then combine for the final solution is the best idea. Sometimes if you're nervous, like on a test, you don't want to do too many things in your head, so lay out each one in the graph and then put the final graph on there. See how your teacher wants that done. There are different types of solutions with an OR inequality. 3 general types are listed below. With one, you're going to use the union symbol between the 2 solutions. Because remember, it can be, if you get a less than and a greater than, it could be either or, so you want to put a union between them. 2 graphs don't overlap, so you have to use that to describe it, because the answer could be either or. And then sometimes the graphs go in the same direction, so you want to use the largest graph of the 2. We'll look at that. And then sometimes if the graphs go in opposite direction, they kind of overlap, and then it could be any real number. So let's try some of these here. All right, here's this one. You want to solve each one. That was step 1. So move the 5 to the other side. 2x is greater than 8. You get x is greater than 4. Or, let's see, move the 4 over. Don't forget to divide by that -1 that's there. So this is going to be x, and you're going to flip the symbol because we divided by a negative, and that's what I'm going to have. Now, 4 greater than 4 would be a soft bracket going that way. -2 would be down here somewhere, and it'd be a hard bracket going that way. So let's see, let's find them on here. So this would be a -2, 3, 4. This would be a 4. So it'd be -2 going that way, and a soft bracket on 4 going that way. Make sure you're clear that I can tell that that's a hard bracket. Okay, do your best on those. And since it's an OR, we want a union. It's just a U without the little thing on it. Here, let me fix that, sorry. Just go like that, okay? And then this side is the -2, going to negative infinity, and then this side is a soft bracket with a 4. Whoops. I don't know what I'm doing. Going to a positive infinity. Okay? So that's one kind of thing. This one, let's see, -7, x is less than 3, or 3, x is less than or equal to a -2. So -2 is down here, and 3 is up here. It says it's going to be less than 3. And then this one is going to be, less than 2. So together it says use the largest one if they go in the same direction. That's important because the solution could be up in this little section up here. So you want to grab all of that. So your final graph should be this one here. Okay? And the interval notation for that one is the 3. Okay? That's the answer to that one. The biggest area, because it's an OR. All right? And then this one here, divide by 10, that is less than 0. Oh, that's weird. That's 2, that's 2. -5r is less than 15 divided by -5. Dividing by a negative flips that around to greater than -3. So 0 less than, and 1, 2, -3 greater than. Oh, okay, since it's an OR, and this covers everything going this way, and this covers everything going this way, your final answer is actually the whole thing, and the interval notation for that is that one. Okay, I'm going to do the rest on another video.